Good day, guys. You are welcome into ID International Academy online class. I want to believe you are enjoying me, we are enjoying each other. And I gave you assignments in the last class. Let's have the solution of the assignment before we go on to today's work. Question number 1 of the assignment is here on the board. Find the order factor if 2x minus 1 is a factor of 6x squared minus 3x. 6x squared minus 3x. Let's try to factorize this expression. What is common to the two terms is 3x. So we have 3x dividing 6x squared, we have 2x. Because if you multiply 3x and 2x together, you will get 6x squared back. So use 3x to divide minus 3x. We have minus 1. So we have factorized the expression. We have two factors in all, 3x and 2x minus 1. And 2x minus 1 has been given to us at the beginning as a factor of the expression. We have to find the other factor. Definitely, as we can see, the other factor is 3x. I hope you get the first one. How many of you got it right when you try your hand on it? Good, I know you could. Question 2. Factorize x squared minus 10x plus 9. Multiply the first and last term together, you have 9x squared. Underline the middle term. Bring the coefficient of this product here. Let's see. 3 in 9 is 3. Can we manipulate 3 and 3 to get minus 10? No, it's not possible. 3 in 3 is 1. We have two factors here. Match them to become 1, which is 9. 3 times 3 is 9. Can we manipulate 9 and 1 to get minus 10? Yes, definitely. We can have minus 9 minus 1, which will give us minus 10. Let's see if minus 9 times minus 1 can give us positive 9, which is the coefficient of the product, which it gives us. So that means these two factors are viable. The factors that can serve the dual purposes, they are the viable factors we can use. So let's write x squared. Instead of writing minus 10x, we now replace that with these two factors. We write minus 9x minus x. We now bring this down, plus 9. If you like, you may rearrange as x squared minus x minus 9x plus 9, so that they will align. 9, 9, you understand? So what is common to these two terms? X is common. So use the x to divide x squared to have x. Use the x to divide minus x to have minus 1. What is common to this, to minus 9x and plus 9? Negative 9 is common. Negative 9 is common. So bring it out. Negative 9 that is common, use it to divide negative 9x. So it gives you positive x. Use the negative 9 to divide positive 9. It gives you negative 1. So you have x minus 1 into x minus 9. That's the factorization. And these are the two factors of the expression x squared minus 10x plus 9. Question 3. If x minus 12 is a factor of x squared plus 4x minus 192, find the other factor. The same process. We have minus 192x squared. And we underline the middle term. In the middle term, we are looking for the two factors whose addition or subtraction will give us positive 4x. And whose multiplication will give us negative 192x squared. So let's go on in search of the two factors. Bring the coefficient here, the absolute coefficient here, I mean without regarding sign. Bring it out. which is 192. 2 in 192, 2 in 19, that's 9. Remains 1. Use the 1 with 2, giving you 12. 2 in 12, 6. Can 2 and 96 give us positive 4 by addition or by subtraction? It's not possible. Go ahead, breaking them. 2 in 96, this is 4. Remaining 1 at 2 in 9, 4. Remaining 1. That 1 with 6 gives you 16. 2 in 16, that's 8. Can 4, because 2 times 2 is 4, can 4 and 48 give us 4 by addition or by subtraction? No, it's not possible. It's far from it. Go ahead. 2 in this, that's 2, 4. 2 times 2 times 2 is 8. Can 8 and 24 give us positive 4 by addition or by subtraction? No. So go ahead. 2 in 24, that's 12. So 2 times 2 times 2 times 2, that's 16. 16. 16. Can 16 and 12 give us 4 by addition or by subtraction? Yes. How? You have 16 minus 12, and which is equal to 4. But let's check their product, whether it will give us the coefficient of the product here. It will be 16 times minus 12, which is equal to minus 192. That means these two factors are viable to use. We now use them in replacement for the middle term by with the alignment of the variable in use. So we write xk. Instead of the middle term, we write plus 16x. Why do we say plus? Because this is not negative, it's plus, invisible. But this is minus 12x. Now adapt this, minus 192. Between xk and plus 16x, what is common? X is common. And if you want to realign them, rematch them, it's allowed. But let's use this. Between this and this, what is common? Only x. X into x in xk gives us x. X in 16x gives us plus 16. So looking into that, what is common to minus 12x and minus 192? You can see it is minus 12. Minus 12 is common. So you have minus 12 into, use the minus 12 to divide minus 12x. It gives you positive x. Use the minus 12 to divide minus 192. It gives you positive 16. You don't just write 16 down here or positive 16 down here because you want to force them to be the same. No. Don't force them to be equal. Let them be equal just by process. So you can now see that we have equal item, equal element in the two brackets. That shows we are correct. So you now factorize finally as x plus 16 into x minus 12. That is the end of the factorization. But the question is, if x minus 12 is a factor of the of xk plus 4x minus 192, find the other factor. We can all see it by ourselves. What's the other factor? X plus 16. You now write, therefore, the other factor is x plus 16. That is the end of it. Let's move quickly to the last question in the assignment. We come to the last question in the assignment. If xk minus 5x plus 4 is factorized into this expression we see, find p and y. Simply, it means xk minus 5x plus 4. By the way, when it is factorized, it is like equivalent to x minus p into x minus y. So let's try to factorize this. Factorizing this, we do the normal thing. Xk times 4, we have 4xk. We underline the middle term. So bringing 4 here. From that, let's bring out the two factors we want to use. 2 in 4 is 2. Can we use 2 and 2 to achieve minus 5? It's not possible, whether by subtraction or by addition. 2 in 2, 1. So we bring this together to be 4. Can we use 4 and 1 to give us minus 5? Yes, it is possible by using minus 4 minus 1 or minus 1 minus 4, either of the two, which gives us minus 5. Now let's test whether minus 1 times minus 4 gives us positive 4, which it is. It gives us positive 4, the coefficient of this. So that means these two factors, they are viable. They are viable factors. So we now write xk. Instead of minus 5x, we write minus x minus 4x, then plus 4. We now equate this to x minus p into x minus y. Let me give space here. Let me clean this so we can have enough space. So we have x minus p into x minus y. So factorizing this now properly, between these two terms, what is common? X. You have x into x minus 1. What is common here? Minus 4. Minus 4 in minus 4x is x. Minus 4 to divide plus 4 is minus 1. We continue, equals x minus p into x minus y. So factorizing this, we have x minus 1 into x minus 4, which is equal to x minus p into x minus y. So we can now begin to do comparison. X minus 1 is equal to x minus p. Then our p is what? Is 1. Look at this. This is this. Why this is this? By simple comparison, x minus 1 is equal to x minus p. If this is equal to this, automatically the 1 here is the same thing as the p here. But by solution, you can write x minus 1 is equal to x minus p. You write this one out. This is equal to this by comparison. Now bringing your p down here, negative p will become positive p, which is equal to x. Taking this x to the other side becomes negative x. Taking negative 1 to the other side becomes positive 1. So you have p equals 1, because negative x plus x is 0 plus 1. Answer is 1. Here. Doing the same thing for the second one you have, and x minus 4 is equal to x minus y, in which you can say, bring this negative y to this side, you have y equals x minus x plus 4, y equals 4. So p equals 1, y equals 4. And that is just the solution. That is the answer to the question. Now, you can see p equals 1 here, y equals 4. But note something on this kind of question. P could also be 4, but if p is equal to 4, y will be equal to 1. If y is equal to 1, p will be equal to 4. That is it. Take note of that. I want to believe all of you got it. So we can now move on to today's work. Good day, guys. You are welcome back into ID International Academy online class. I hope you enjoy the last class with me. Today, we are going to consider another subtopic under algebra, which is algebraic expansion and simplification. Example 1. Expand the following. A, x minus 3 in bracket into x plus 2 in bracket. B, x plus 4 in bracket into x minus 1 in bracket. Question A. There are two approaches to this kind of question. Number 1, you could use one bracket to expand the other. What do I mean? If you want to use this bracket to expand the other bracket, take the first element in this bracket, in this one, use it to multiply the second bracket all together. Now, take the second element in the same bracket you have taken before, which is minus 3 now. Use it to open the same bracket you are opening. Now, open this bracket with x. You have x squared plus 2x. X squared plus 2x. Open this other bracket with minus 3. You have minus 3x minus 6. You have to simplify this. X squared minus x. How? Positive 2x minus 3x gives negative x minus 6. That is the result. If you want to use direct approach, x minus 3 into x plus 2 will give you the product of the two variables there. X times x, that gives you x squared. That is direct approach. Now add the two constants together. Whatever you get will be the coefficient used with the variable. That is minus 3 plus 2. That gives minus 1. So you are now going to write minus x. Instead of writing minus 1x. It's the same thing as minus x. Now, lastly, multiply the two constants together. Minus 3 times 2, that gives minus 6. That is direct approach. But this direct approach is only possible when the coefficient of the variable in the two brackets is 1 in each case. 1 in each case. As you can see, coefficient of x here is 1, of x here is 1. If the coefficient is like 2, or here 3, something like that, you cannot use that direct approach. You have to do the expansion practically. Question B. X plus 4 into x minus 1. Using this bracket to open the other, you take x into x minus 1. The second element in this bracket, use it. That's plus 4 into x minus 1. Open the bracket. You have x squared minus x. Open this other bracket as well. You have positive 4x minus 4. What are we doing? You use x to multiply x, you get x squared. X times minus 1 minus x. Plus 4 times x plus 4x. Plus 4 times minus 1 minus 4. So finally we have x squared plus 3x minus 4. What are we doing? Negative x plus 4x. That gives positive x. Now, to have this one also directly, direct approach, you have x plus 4 into x minus 1, which gives x times x, x squared. Add the two constants, positive 4, add it to negative 1, that gives you positive 3. That positive 3 is the coefficient of the variable. You now have positive 3x. Multiply the two constants, positive 4 times negative 1, that gives you negative 4. You can see that the answer will be exactly the same. What we get here when we do the pragmatic approach is the same thing we do here when we do the direct approach. I want to believe you understand. Good. Let's go to example 2. Example 2. Expand the following. Here, x minus 3 all squared. There is a particular approach that is good for you to use for this kind of expression. And that's exactly I will explain to you. Nonetheless, there are other ways of doing it. But I want you to get that one because it saves time in the exam. And nobody cares whether you use one method or not, apart from in cases where some method will be required, but not in this kind of topic. Whenever you see anything like this, there are 3 steps we take to expand this kind of expression almost seamlessly.